Our next article in this topic is about solubility and solubility product. Solubility means solubility of sparingly soluble compounds, because highly soluble compounds, their solubility can be measured experimentally directly. So we shall be dealing with solubility of sparingly soluble compound. Let us begin with the definition of solubility itself. Solubility S is usually defined as the number of moles of a substance soluble in 1 liter aqueous solution so as to make it saturated at constant temperature. The unit of solubility is nothing but the unit of concentration, that is mole per liter or capital M. The next term is solubility product, which we represent by KSP. It is defined as the product of the concentration of the ions of the sparingly soluble compound in its saturated solution at a constant temperature. For example, if we consider the dissociation of silver chloride in aqueous medium by the equation AgCl solid equal to Ag plus aqueous plus Cl minus aqueous, the solution is saturated, then KSP is equal to Ag plus ion concentration into Cl minus concentration. Similarly, for strontium fluoride SrF2, the equilibrium will be SrF2 equal to Sr2 plus 2 fluoride ions, and therefore expression for KSP would be written as KSP equal to Sr2 plus into F minus raised to power 2. Remember, KSP is an equilibrium constant which is constant at constant temperature. If the solubility of a substance increases on increasing temperature, then the numerical value of solubility product will also increase on increasing temperature and vice versa. One more term we must understand before we go into the details of this part of the chapter. The term is ionic product, written as IP. However, if the solution of the ionic compound is not saturated, then the product of the concentration of its ions is known as ionic product. It's important to note that the concept of solubility product is mainly applied to the sparingly soluble compounds like AgCl, AgBr, AgI, PbCl2, CuS, FeOH3, MnS, BaSO4, etc. Now, let us see a generalized expression for solubility product KSP. Consider a sparingly soluble ionic compound AXBY with A plus Y cations and B minus X anions. If we add 1 mole of this compound to water so as to make 1 liter solution, most of the salt in the solid form or as a precipitate will appear to us, and a very small amount of it will be in the solution state. So we can write equilibrium as AXBY equal to XA plus Y plus YB minus X. 1 mole of AXBY in the beginning is taken so that the products were 0, 0. The solution is of course saturated, and suppose the total volume is 1 liter. Let the solubility of this compound be S mole per liter. Then at equilibrium state we will have the concentrations S, 1 minus S, XS and YS moles per liter. Therefore, according to the definition of solubility product, we can write KSP equal to X xs to the power x, ys to the power y, and that's equal to x to the power x, y to the power y into s to the power x plus y. Mark it as equation number 1. Now let us take some specific examples of sparingly soluble compounds to develop the relation between solubility product and solubility individually. First of all, we consider compounds whose cation and anionic valencies are same in the category A. For example, AgCl, AgBr, AgI, they are known as univalent compounds or salts. BaSO4, C2O4 as bivalent and FePO4 as trivalent.